everyone, and welcome to PyData Global. We're excited to have you join us. Feel free to use the chat to connect with fellow attendees and share your thoughts during the session. If you have any questions, please post them in the Q&A tab and we'll address them at the end of the session. Now, it's my absolute pleasure to welcome Hugo. Let's give a warm virtual welcome to Hugo.
Hi, everyone. Hi, Patricia. Welcome, everybody. Hugo Bowne-Anderson here. I'm so excited to be back at PyData Global and to be, I think, one of the first sessions here, and grateful to the team for being able to organize it so I wasn't speaking at 3 a.m., which is better for everyone, I must say. I'm really excited to be here today to talk about building AI-powered applications, in particular for data people and software people. I put the GitHub repository in the chat as well. But let me just say a few things about myself first, just by way of introduction. So just quickly, a bit about me. I'm Hugo Bowne-Anderson. My background seems many moons ago now was in biology, math, physics. Did a lot of work in early data science and machine learning when I was working at DataCamp, and then been involved in the SciPy ecosystem, doing developer relations and a variety of other things, and the PyData ecosystem for the best part of a decade now. And I can honestly say the SciPy ecosystem and the PyData ecosystem is one of the many reasons I'm still around. But the community here is so important to me, and so grateful to be welcomed back here again to work with you all. I have a couple of podcasts if you want to check them out: Vanishing Gradients and High Signal. I currently have my own business building AI systems, consulting, writing, teaching, have a variety of courses, and say hi on LinkedIn and or Substack. Substack seems to be a place where we can have perhaps higher signal conversations these days. So do reach out on either of those places. So I just want to say a bit about this, pardon me, a bit about this workshop. It's going to be an introduction to the burgeoning, somewhat new, somewhat machine learning and data powered products, old AI software development lifecycle. And we'll explore a bunch of themes such as integrating AI models and APIs into applications, prompt engineering and controlling output, monitoring and evaluating AI systems, structured output, function calling, and multi-LLM and agentic workflows as well. Now, this is a not insubstantial amount, and there is so much in this space to talk about and think through, but I wanted to go for breadth rather than depth and give you kind of a sense of the variety of things in the space. And to that end, the GitHub repository has an application directory, which we'll see soon, with 7 different apps in it, and it has 4 notebooks as well. And we won't be executing all of that code in real time. And I actually would encourage all of you to not try to execute the code while we're going through it. Watch me execute some of it, and then afterwards, get it all up and running yourself. And I'm here to help on the GitHub repository and also here throughout the conference as well. So just a bit about the flow of this session. I want to start by just really thinking through a bit about what AI is and why it's useful, or why it's promising even. Then talk about the trap we fall into a lot of the time with proof of concept purgatory. Then try to get a feel for what happened, and then see how we can come out of that and start building systems that we actually can understand ourselves. Then how we can get our AI software starting to do things. And this is moving along the agentic spectrum. And then I want to talk about kind of the 2 cultures of AI agents. And one is something that seems really important, like starting small and building up so you can understand your system. And then we have the top-down approach, which is building these, YOLO agentic systems, which 6 months ago I would have told you not to bother with, but now it seems like they can be increasingly powerful. So firstly, I think we all have a sense of what generative AI is, but I had a chat with Gemini and told it I wanted to give a slide on the promise of AI, and I wanted to focus on 3 things: chat, search, and action. And it decided with the word promise to make it the most bland, banal AI slop marketing material one could possibly present. Thank you, Nano Banana. But it is instructive, because I do think we throw around what AI is capable of a lot of times. But I do think there are three things that really are super important in AI at the moment. The first is chat, of course. I don't need to tell you all about that. The second is search. And essentially, the way I think about search and the way a lot of us think about search is really, you may have heard terms like context and context engineering. It's how we can get the right information in the right form to the LLM, right? So that it can provide the answers, perhaps with sources as well. And the third is action. So this is moving more along the agentic continuum, but this could be an action such as create a dashboard or create a slide deck, or it could be send an email, all right? Now, it could also involve robotics and these types of things, but I'm really talking about software action here to start off with. And these are the three places where we're seeing a lot of focus on product and a lot of value being delivered, and a lot of promising value as well through chat, through search, and through action. So I just want to, I don't need to convince any of you of how chat is everywhere currently, but this is an example of, you may have heard of an app called ChatGPT, right? So this is its most recent incarnation, 5.1 thinking, where you can have a chat with it, and now it will create some marketing dashboards for you. Okay, so this is chat kind of combined with some sort of action and perhaps search as well, but I'm kind of showing you the chat interface. This is Claude artifacts, right? Where I'm able to generate a custom timer, it will render it, and it's interactive and usable, right? So I do this through a chat interface. And then this is me playing with Gemini 3 and Nano Banana in Google AI Studio. And I said to it, this is a photo of me, can you put a banana on my head? Not only did it put a banana on my head, this is actually quite odd. This is incredibly rare in my experience. I didn't even respond to that. And then it put another banana on my head. So I got two for the price of none. Because of course AI Studio is free. Of course, that's not quite true. We pay Google through attention and data. Never forget. So clearly chat is important. Then why do we care about search? Now, I love this question, and that's why I'm asking it. Search, anyone who has tried to get information from an LLM, like correct information, grounded information, will have experienced significant frustration, right? They're not up to date. They have cutoff dates. They don't even know. I mean, Gemini 3 doesn't even know about the existence of Gemini 3, right? It constantly thinks you're talking about Gemini 2.5 when trying to work with it to write Gemini code. So filling knowledge gaps is incredibly important. Grounding and accuracy in your own documentation is super important. Having task-specific relevance. So if let's say at the end of this, I want to turn this workshop into a blog post, right? I want to ingest this blog post and form a pipeline around the specifics of what happens in this workshop. As I've mentioned, dynamic and up-to-date information. So grounding your LLM in, what happened today, getting it to do web searches to do that, incredibly important. Also, enabling explainability. And I really like this use case. So this helps us understand where information comes from, which we may have forgotten, but this can be somewhat important. A lot of people are doing a lot of great work on this. This is an article from O'Reilly Radar last year, saying the R in RAG. And if you don't know what RAG is, you probably do, but if you don't, this is a form of retrieval, a form of a form of search. And the joke is the R stands for royalty. So what O'Reilly has done is they've used a retrieval system. So when you ask a question on their platform and it gives you an answer based upon something from one of their author's books, that author will get a royalty there, right? And I think these types of things are wonderful. So we've talked about chat, we've talked about search. Now let's talk about action. So LLM's actually doing things. They can generate text, but can they actually do things? And this is super important, right? Because I think a negligible amount of the economic value of AI will come from chat interfaces, particularly because it's upper bounded by human time, right? And human attention. So the ability for LLMs to generate things will be incredibly important. So what we're talking about here is automating workflows, interacting with external systems like databases and APIs, perform calculations. Who would have thought that the best way to get a piece of software to perform calculations would be to give it a sandboxed Python environment and build a calculator for it? And essentially, as it turns out, that's one of the best ways to be sure that LLMs are doing correct arithmetic. So specifically, we want them to be able to retrieve information, so access external sources like databases, APIs, or knowledge bases. We want them to be able to run code. We want them to be able to use tools. So that's interact with external software or services like email clients, calendars, image generators. We want them to be able to handle multi-step tasks and break down complex problems into smaller sequential steps and coordinate their completion. We also want them to be able to trigger actions. So the LLM output in that case would be activating appropriate strategies, tools, or next steps based on context and inputs. Now, we'll talk about this a bit later in this workshop, but one way to think about this is starting to augment your LLMs, not necessarily jumping to full-blown agents. And this is from an Anthropic blog post from late last December called Building Effective AI Agents, which if you haven't read it, it's must read. And essentially, before going along and starting building workflows out of different LLMs together, they make very clear that LLMs are tokens in or words in and tokens out, right? They don't even have memory. When you build a product like ChatGPT or Claude, you're including some sort of memory in your software there. But so if you need memory in your system, you need to start thinking about reading and writing memory. When you want to query documentation, which most of the time, or the lion's share of the time, you want to start thinking about retrieval. And when you want to start using tools such as, ping an API, you want to be calling and responding there. Now, before wrapping up this section, I do want to just give a bit of future music. I really like Andrej Karpathy and a few other people have talked about the idea of an LLM cognitive core. And this is essentially the idea of a small model that sacrifices all of its knowledge for capability. So it doesn't really have information in it, right? But it's very good at retrieval and very good at tool calling, for example, and a lot of multimodal stuff, right? So as Karpathy says, it doesn't know William Conqueror's reign ended on such and such a date, but it vaguely recognizes the name and can look up the date, right? And I'm very attracted to this because not only does it help you avoid the hallucination problem, but I think it really helps use an LLM for what they can be very good at, which is these types of capabilities, from multimodal stuff to the tool calling to search, without all the pain they give us. So that's on the user side. Now let's start building some things, right? That's what we're here for. So I just want to say, most people, when they start building with AI, will get into proof of concept purgatory. And I'll just say, PyData global team, I can't see any questions or anything in the chat. So if people are asking questions, just know that. So if you see any questions, feel free to turn your microphone on and let me know. But something that happens with traditional software, it's usually pretty boring at the start, right? You have a hello world, basic features, add unit tests, and you slowly get more and more excited, scale and optimize, load balancing. Whereas with generative AI, you start with a flashy demo and it's like, bam, this is cool. And then you're like, wait, does it do what I think it did? And when someone tries to do that thing, does it also do the same thing? And it's like, oh, wait. And then you start dealing with hallucinations, and then you can't see the internals of your system, and then you can't integrate it with your pre-existing enterprise stack. Okay, and excitement goes down and down and down. And I don't want to change anything about this figure. I don't even want to change the excitement of the flashy demo. I just want to keep us like monotonically increasing, right? Up and to the right. Not in the VC sense necessarily, but up and to the right. I don't want, there'll be kinks and bumps and that type of stuff. But I don't want us to be descending into proof of concept purgatory like this. So to that end, I want to show you a piece of code which will then execute in the GitHub repository. And this is a framework called Llama Index, which is a fantastic framework for so many things. And there are lots of great frameworks as well. But one challenge with frameworks is adopting them too early, right? And so if you adopt a framework like this too early and write 5 lines of code to get a retrieval system, you can get stuck in proof of concept purgatory. So let me show you. I wrote these 5 lines of code, and you can see I'm doing my imports, then setting up my documents from a data directory, setting up some index and a query engine over the docs, and then I'm saying, who is Hugo? And I'm putting my LinkedIn profile in it. And that's not for any solipsistic or narcissistic reasons. Essentially, it's so that I can see whether the output is correct, okay? And when I run that file, and we'll run it together, or I'll show you, it says Hugo is a dedicated visionary. Okay, maybe I do like this piece of software, actually. An intelligent individual, yada, yada, yada. Okay, so it comes out with something that looks all right. What we can then do is add a UI in 7 more lines. And I'll show you this in the repository in a second. And then what we get is something like this. So this is a short video of what those lines, literally those lines of code I just showed you. And I'm dragging and dropping my LinkedIn profile and querying it. I'm going to say, who is Hugo? And it should come back in a second and say Hugo Bowne. Okay, great. It did all right. And now I'm saying, who is Stefan, who's a collaborator of mine who works on agent infrastructure at Salesforce. It says there is no information provided about Stefan in the context. That's cool, right? Because he isn't in my LinkedIn profile, as far as I know. So then I decided to write, who is John? And it says Hugo Bowne-Anderson hired the company's first content developer, Yashis Roy, who later led the content team. Okay, not only does this not answer the question, it answers a different question, doesn't mention John, and on top of that, I just wrote these 5 lines of code. I don't even know what it's doing with my document, right? So when it works, it's great, but like, I don't even know what the actual prompt sent to the LLM is. I don't know how to give feedback on system performance. I don't know how I can see the conversations or the data or the traces. I don't even know how to iterate quickly on it because I don't know what's happening inside the system, right? And this actually was such an issue and continues to be such an issue that my friend Hamel Hussein wrote a blog post that you can Google if you'd like, called FU, Show Me the Prompt. Because when prematurely using frameworks, a lot of the time they will hide, not intentionally, right? And they actually did it, I think, generously so that developers didn't need to worry about everything that was being sent to the LLM. But in the end, as the developer, you need to see the prompt. So we should be adopting frameworks that hide the things we don't care about and show us the things we do. And in this case, this early in the system, we definitely want to see the prompt. So without further ado, I'd love to jump to GitHub and let me get this right. Let me just confirm. Okay, great. So as I said, I encourage you all to not try to code along with me, okay? Because we'll be moving somewhat quickly. So I encourage you to watch and then go to the repository and code along afterwards. And I will put this once again in the chat and fork it, star it, raise issues, etc. Issue a pull request, but remember, giving someone a pull request is like giving someone a puppy as well. It's really lovely and thoughtful, but we need to feed them. And what you'll do, I mean, all the instructions are in the README, but I've set it up so you can run everything on a GitHub code space. Okay. So for those of you who haven't seen GitHub code spaces before, essentially, if you've seen VS Code, it's kind of like VS Code, right? But in the browser, and I've been able to say what packages exist here, okay? So you'll see I have a requirements.txt where all the Llama Index stuff, OpenAI, Anthropic, Google, Gradio, Python stuff, PyData Essentials. And yeah, so it's kind of like Colab, but with VS Code. Really, really fun, cool stuff. So in the README, what I talk you through is what you'll learn, then the workshop structure, and then the setup. Okay, so I'll encourage everyone to go through this. You need to activate the environment. Once again, don't do this now. You need to copy the .m.example to .env and then put your keys in here. And you can actually get a lot of the way just using a Google key, actually, which you can get for free from AI Studio. Okay. If you want to do it locally, all the instructions there as well. So first order of business, I'm going to jump into notebook one, and notebook one has no code because we'll be actually executing apps here, and it talks through the setup. But what we're going to build is we're going to build a query app, the one we just saw using llama index abstractions. Then we'll build a vanilla Python version. We're going to come back to build the vanilla Python version where we control every line of code. And then we're going to add logging observability with SQLite. And then we're going to build a multimodal app that can read PDFs directly. So I've done this, but you'll go through and set up your API keys. And now what we're going to do is we're going to start with the first app. So let's go into apps and just have a quick look at this. And look at this. This is exactly what I showed you already. Okay. And I'm going to execute this. So let's now, and we'll talk about what this abstracts over. I need to CD, and let me know if you want me to make my screen any bigger. I can't make it much bigger than this, to be honest. So let's go into the apps directory, and I'm going to Python run one app query, right? And it's looking in the data directory. And while it's looking in there, and the query we're sending is tell me everything about this person. Okay, let's look in the data directory. We have two things. Oh, great. The demo guards are not shining. We have the text of my LinkedIn profile, and we have the announcement, the old announcement about OpenAI 01. So I just did that as a distractor. So I think perhaps if I need to just source my environment again because the code space shut down. And let's see if this works. The demo gods can be incredibly spiteful, as we know. Okay, this worked. This person is Hugo, blah, 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 blah. Okay. Now, as I said, this is incredibly powerful and super cool for a demo. Literally, these, besides the print, these 5 lines of code have been able to ping an OpenAI API and feed it all of this data, right? I do want to just show you, I've got 2 other apps for people who want to play around with them. One is doing it with Gemini, and we can see that in here, and we'll see what this means in a second. But what I needed to do was set up an actual embedding model myself, a Google, a Gemini embedding model. Llama Index doesn't natively, it natively uses OpenAI. So I would either have to use a key, or set an OpenAI key, or use a Gemini embedding model. And I've also got a script which you can look at and play around with, whichever is your preference, which queries it using Claude. And look at this. Look at this. So we're running the Claude one now as well. Oh, my face is hiding. Oh, it looks like I can drag my face around. That's cool. Okay, so this is what it looks like from Claude. Okay. Now, the reason I wanted to show you these 3, and maybe you've had a lot of this experience yourself, I'm not certain, and feel free to let me know in the chat as well. But we already see these LLMs have different flavors and different smells. I mean, OpenAI's GPT-5 has just given me like a paragraph, right? Now, Gemini has been more verbose with bullet points. Great. And Claude has actually given me Markdown, which I kind of love, to be honest. I would prefer one that just gives me JSON without me having to ask for it, but we'll see how to get that up and running pretty soon. So this is great. We've been able, in a few lines of code, to build some form of search retrieval system, right? Now, as I said, we can also add a front end to it, and you can have a look in the notebook for more of the details of how I do that. But I really showed you in the slides as well. And so I'm going to, whoa, no. We're not going to jump to the third one yet. So I'm using Gradio. If you haven't used Gradio, it's super cool. Great for shipping prototypes like this. Works really well in the entire ecosystem. It's out of Hugging Face. So it's just created a little app for me to start with. And look at this, right? So let me just go back and I will actually show you this code. To drag and drop the PDF, I actually need some extract PDF functions. So I do that, and for demonstration purposes, I'm using PyMU PDF. I wouldn't use that in production. But once again, in 41 lines of code with these Gradio blocks, I get something like this, right? And let me now just drag and drop a PDF into it. Just to demo that, you know, what I'm saying I'm doing is actually what I'm doing. Tell me everything about the person in this PDF. So I'm chatting with that just using some software called Super Whisper I have on my laptop. Okay, the individual mentioned in the provided context is Hugo Bowne-Anderson. Okay, great. I'll see what happens if it says, who is John, actually. There is no information provided about a John in the context. See, that's interesting. That isn't how it responded last time. Once again, we're seeing the non-determinism at play. There wasn't actually a space when I did it last time. Oh, look at this is amazing. Who is John? The answer is Hugo Bowne-Anderson. Absolute nonsense. I love it. I would love it more if I could inspect my system. But really, what I wanted to demonstrate there was how easily you can get up and running with pretty cool software. But when you adopt frameworks too early, you do end up in a space where an uncomfortable space where you don't know how to work with these systems anymore. So what we're going to do next is start jumping into how to build these more robustly. Okay. So let's just diagnose what just happened. We actually built a basic retrieval system. And I've spoken to this already, but retrieval is a fancy term for giving an LLM the context it needs to answer your question better. So examples are an FAQ bot. A user asks, what's your refund policy? And the system retrieves the company's policy doc. And then the model answers using that text instead of quote unquote guessing. A code assistant. User asks, how does our data loader work, right? And the system retrieves relevant files from your code repo instead of relying on its weights, right? And passes those relevant files into the LLM prompt. So what we just built, essentially, the user sent something, a doc and a query to the front end UI, and then there was some sort of context enrichment, and that pinged the LLM API. We use Gradio here, we use Llama Index here, and there are we actually use all three APIs there. I see Oren has a question. I'll provide it afterwards. If you do want to just Google building effective AI agents, it will come up. And if you could paste that in now, that would be even better. But I am happy to provide it afterwards. So, what actually happened under the hood when we used Llama Index? Then the user, in this case me, sent a question to the retrieval system. It retrieved the relevant context from the docs, right? Only then did it pass the query and the context to the LLM. Then the LLM passed the response back to the RAG system and it passed it back to me. Okay. Now, how did this retrieval work? In this case, it uses what are called embeddings and retrieval, which we're not going to go into too much today. But know that this is one of the reasons the term RAG is kind of silly. I mean, even if we weren't using, like, RAG generally means this, where you use embeddings and then you use the results of the embeddings to put in the context. But retrieval could involve, we're seeing a lot of interesting agentic retrieval these days as well. And that's not classic RAG, but it's retrieval augmented generation, right? So what I want to do is just step back and say, all this is doing here is kind of the search stuff that I was talking about earlier. And it's what we've classically called RAG. So having said all of this, and thank you so much for finding that, Oren, as well. Let's now think through how we would build a system that we actually understand, right? So what I'm going to encourage you all to do when starting off here is to write pure Python. Just write some Python code, or get your AI assistant to write some Python code. Use an LLM API or a local model, and then add a framework later. I love a lot of the frameworks, but what we want to do is make sure the frameworks abstract away code we don't care about. Okay, and here I couldn't see the bloody prompt, so it was abstracting away code I did care about at this point. Sam Hogan tweeted out a while ago, and this is something I've just seen so much, but I think it's really important. I just want to, like, quote unquote double click on this. Is what we're all seeing in the space, is that the most consistent thing that Sam heard was that people stopped using LangChain and other agent frameworks such as Llama Index and built their own internally, as it works way better and easier to use. And he makes the point that we still haven't found the right abstractions for building with LLMs. And essentially, we've got these incredible horizontal technologies in foundation models and frontier models. We're trying to figure out how to build on the application layer, and people building frameworks are trying to figure out what will be useful while we're all trying to build on the application layer. So the expectation that we'd have the right abstractions, I think, is ill-founded. And all these frameworks are doing incredible work. But Sam actually makes the point that React didn't come out until 2013, many years after web apps became popularized, right? Which I think is a nice way to set expectations. And I just wanted to share a slide that my colleague and friend Stefan, who I mentioned earlier, who I teach a course on all of this stuff with, this is one of his slides that I really like, which, when choosing frameworks, you really want to understand what they're optimizing for, right? And I think, and I agree with Stephanie, the best way is to understand who the people are who created it. So, for example, if someone has created a framework and they've been building successfully in the open source space for a decade, that's someone whose framework I'd probably be more interested in adopting, because a lot of these things are community driven and community generated as well. They should make iteration faster, right? And they should replace code you don't care about, as I said. So this is what we built. But what we really want instead is a front-end UI. We want to ping an LLM API and give it our own context somehow. We want to make sure we log it and that we can see our traces as well, in order to understand what's going in our system and what's coming out of it. So what we're going to do is we're going to do exactly this. We're going to use Gradio, Gemini. We're going to use SQLite. We're going to use Dataset. Somebody wants to find the link to Simon Willison's incredible tool, Dataset. Please do paste it in the chat. And you can also export to CSVs, and spreadsheets will be some of your best friends here as well. And then we're going to see how we can add some multimodality here. So all that having been said, let's go to GitHub again. And hopefully my code space hasn't timed out. Very cool. It has not. Now, let me just make sure. Okay. So let's, just gonna make it a bit smaller. Let's go back to notebook 1 just to see what we're doing next. So what we're going to do is we're going to strip away Llama Index. We want to see exactly what we're sending to the model, okay? So we're going to manually open and read a file, construct the prompt, and then call the API. So this is in 3 vanilla Python query. So let's look at this. And I'm choosing the other file just because I'm sick of looking at the results of my own LinkedIn profile. I mean, I really buried myself with this. So what we're doing is we're opening the file and loading it as a string into document text, right? Now creating a prompt to send to an LLM, which is, just close that. The prompt is, context information is below. I'm including some structure to it so it can parse it, giving it the document text. Then I'm saying, given the context information and not prior knowledge, answer the query. Then I say, query, what is O1? And then I prepend answer to make it easier for the model to give its answer. We don't really need to do that these days. but it can be useful. And then what I do is I'm using the model Gemini 2.5 Flash, which if you use a key from AI Studio, they have a free tier. It's like, I think it's the only frontier model that has a free tier, which, I mean, it kind of boggles the mind, to be honest. And then what I'm doing is I'm sending this prompt, which contains the document and what I've written here, to the model, and we're just going to print the response. So why is this so powerful? Because I know what I'm sending to the LLM here, and I'm not doing any chunking, I'm not doing any embeddings or anything like that yet. And I don't need to, because it's a one-page LinkedIn profile. So I'm sorry, this isn't the LinkedIn profile, actually. This is just the O1 announcement. So let's now run that. I mean, who knows? Okay. This is cool. Answers the question pretty well. O1 is a new large language model. And now I'm just going to see, it's interesting that when I did it, tell me everything about this person. Let's now, is it called hba.txt? I think it is. Let's just see whether this is it. So Moo, I'm sorry if you mispronounced your name, says send material presentation. I'm not sure what the question is. Is it my slides you're asking about? So this is great. Because it's Gemini, it's quite verbose. We see it's done exactly what I wanted it to. Fantastic. Outputs a bunch of stuff about me from my LinkedIn profile. Very cool. And we know what prompt is. Prompt has been sent. Now, why does all this matter? Once we start logging our traces and monitoring, and by traces, I mean the ins and outs, essentially, and having monitoring tools to see what's up, to see what's happening, it can help us iterate quickly. So what I want to do is show you, let's go back to the notebook. What I then did was I created the next version, which is rebuilding the front end with Gradio. And then, and you can go through that app in app 4 if you want, but what I then did was started adding logging and observability. Okay, so essentially what I'm doing is spinning up a basic SQLite database in order to write the traces. And oh yeah, I'll provide the slides, Albert, at the end of the workshop as well. I just don't understand yet Moo's question, but I will share the slides at the end of the talk. But you don't need the slides right now because I'm giving the talk. So for logging and observability, this is app 5. And once again, what I want to do here is not take you through all the code. I'm happy to chat about it afterwards. But the details of the code aren't, like, you can do this in any number of ways you want. But I want to show you how you can spin things up relatively easily. And so what I'm essentially doing is creating a SQLite database, initializing it in order to log everything to it. And if I can, my terminal is back. Fantastic. What I'm going to do is now run Python app 5, and it'll create a Gradio app. And I'm going to, once again, put my LinkedIn profile here. Who is this LinkedIn profile about? And note, I don't even have any conversations here yet. What is all of this nonsense? See what it says to that. Okay. I like that it answered that like that. Now, I just wanted to give a couple of examples there to show the results of us logging now allow us to now, what we'll see is that it's created a database in the data directory called interactions database. And what I can do is I can use this dataset tool, which our friend kindly linked to. To inspect everything we've just written to it. And it will kick up a server here. Check this. And look, I have this nice little interface to explore what's happening here. And I can, if it was more complicated, I could write SQL code. And here I can actually see, look, I can see the query. Who is this LinkedIn profile about? Hugo Bowne-Anderson. What is all of this nonsense? This document should say this nonsense. On top of that, I can download, export as a CSV, do advanced exports, and oh yeah, Aliaskar has said dataset tool is so cool. Totally agree. Also check out Simon and check out everything Simon does, but his LLM client utility tool is a boss move as well. And so this is a way to start looking at your data immediately. And look, the real takeaway I want to give is if you're using vanilla Python and some API calls to start out with, start logging and get observability. Then you can see what's happening in your system. The LLM may be a black box, but the system you're building doesn't have to be. And that's one of the most important takeaways here. Okay. So the last thing I want to do before going back to slides is let's go back to the notebook for 1 second. So we've just visualized with dataset, going multimodal. Okay. So we were using, FITS or PyMu-PDF to extract the text. The models are getting so good, I'm just going to go multimodal, and Gemini 2.5 will extract the text and do image explanations for me, essentially. Captioning or however you want to think about it. So what I'm going to do is run Python 6 multimodal PDF extraction. What I'm feeding into it is, and I'll show you the script in a second, a PDF here. Now, I can't render it correctly in the code space, so I'm going to show you. It's from the Behavioral Insights team, and it's an incredible paper they wrote recently on behavioral all types of behavioral things with respect to how we can augment, adopt, and align with and adapt to AI. I actually did a podcast with Elizabeth Costa from Bit recently about it, if you want to check out the High Signal podcast. But I wanted to use this because it has a bunch of cool images and that type of stuff, right? So I just wanted to make sure how Gemini could work with it. And Gemini 3 is even better. But let me show you the prompt I've given it. So I'm passing it the PDF, and I'm saying I'm using 2.5 Flash, 2.5 Pro, you'll get even higher performance, but I'm saying extract all the text in reading order, return markdown, do not summarize. For each image encountered, insert a placeholder like image 1, image 2, in the order they appear, etc. And include a brief description of the image plus any visible caption, title, figure, and so on. And I've had it output the text here. So it's also saved to extracted text, and we can see the text. This is good. Okay, let's see, has it done any images though? This is pretty cool that it's extracted tables as markdown pretty well. Now, where are the image? Okay, great. Image 3, a flow diagram illustrating the continuum of AI adoption from no adoption to shallow adoption to deep adoption with barriers and enablers. No adoption has motivation and trust barriers. So it's going through this image. So it's literally, this doesn't have a caption. It's going through and doing its best to explain to us what's happening in this image. And this is kind of the beginnings of how you can think about multimodal AI. You may want to store the images, not using Gemini somewhere, and have them referenceable from the text as well. But this is kind of a first foray into even exploring the multimodality of such modern language models. Casimir has a comment. The black box argument is actually a great point from a Python perspective. Yeah, you're using Imagic, for example, also a black box, but thinking of LLMs as some sort of surprise library service helps a lot to demystify them. I agree, and I do think, as I said, LLMs are wild black boxes, so we don't need black boxes around black boxes, really. So that was a little foray into the multimodality of such things. I did want to say, if you do want to learn more about multimodal AI, guess what? I do too. And I'm running up because I want to learn more about multimodal AI. I mean, I build a lot of multimodal AI stuff, but I want to learn from the best. I do online workshops, which are free on the Vanishing Gradients YouTube channel. But this is one that I organized with Marcel and Alison from Pixel Table, where they're doing wonderful multimodal AI stuff. And Marcel is a co-creator of Parquet, among Impala, among other things. So, wonderful people. And they just messaged me the other day saying, "Hey, Wes McKinney wants to come as well and have a chat about multimodal stuff." So we'll be doing this next week for those interested. So we've talked about build a system you can understand. Now it's important to talk a bit about evaluation, because you can't really understand something until you start thinking about how to evaluate it. This is something that's called evals as well, but all it means is making sure your system and product works the way you think it does and making sure you can iterate on it, okay? So really what I want to say is we need some way to evaluate our system. So we'll build an MVP, we'll deploy it to users, we'll observe its behavior, and then we want to make improvements, right? Now, what does observing behavior look like? Oh, this is evaluating. And what does making improvements mean? It can be prompt engineering, it can be fine tuning, it can be retrieval, etc. And once we do evaluation, that will help us figure out which levers to use. So Stephen says, Hugo, great talk. Thank you, Stephen. How much code are you writing with assistance, agent workflows compared to hand coding these days? And what would be your advice for AI assisted coding in production? In an ideal world, I would write no code anymore at all. I try my very best to not write any code at all. Yet every day I'm finding myself writing code, particularly when trying to make things like production and reliable and robust, right? So having said that, I use Cursor for the most part. There are other tools I use, but at the moment I'm using Opus 4.5 and Gemini 3 for a lot of my work in Cursor, and then smaller models for execution stuff. So these models are very good at writing code that's represented in training data, right? And a lot of the code, not all, but a lot of the code that I need to write is represented in training data. And like SciPy, PyData stack stuff, so your pandas, right? And Matplotlib and NumPy and all of that, you can do a really good job at. Cutting edge, new releases of Pydantic AI and these types of stuff, it's not great at. Having said that, you can paste in the documentation and it gets pretty good then. I do think, Andre Karpathy recently said on the Dwarkesh podcast, he mostly uses code completion. That's because he's writing, real bleeding edge, cutting edge stuff, which just isn't represented. My major beef with these systems are, even when you in your agent MD or cursor rules or whatever, specify, how you want it to write code, that you don't want it to be too verbose, that type of stuff. They will still write sprawling systems. So you need to constantly pull them back. And sometimes it's easier just to, write a few things yourself to deal with that. So I hope that is helpful. I do feel I am more a manager of code agents writing code than I am a code writer myself these days, for what that's worth. So But great question. And so thinking through what we need for evaluation, um, let's just go through an example, right? So we've looked at LinkedIn profiles. So let's think about an application that takes in LinkedIn profiles, finds relevant candidates for a position, automates emails for them. Now, I don't want anyone to build this. The world does not need more automated recruitment emails. Okay. But for it's an example, a nice example, because you see several steps in here and different types of things you're looking for. So you can ask at a micro level, is the information it extracts from LinkedIn correct? And you want to evaluate that, right? Does it give you the JSON you want to feed into the next step? Does it give you the correct title, job history, skills, that type of stuff? Now, then you can ask, do the emails generated resemble the emails domain experts sent previously, right? That's a bit more interesting. And perhaps getting a domain expert in the loop, the person who sent the emails previously, to help evaluate the output of these LLMs could be useful. Actually, enabling them to write prompts could be incredibly useful as well. And some of the best systems I've seen actually have domain experts in the loop writing prompts. Setting up systems in your organization where, even if it's a Slack channel, where domain experts can collaborate on prompts. But in the end, neither of these things matter if the emails don't result in hiring good candidates more quickly, and good candidates that stick around the company more quickly than the previous system, right? So we always want to have, and this is, of course, a seriously lagging indicator. We can do a lot of evaluation at the technical level. We always want to do our best to tie it to evaluating the business impact as well. So when doing evaluations with respect to LLM output, there are many ways to slice it. The first most useful way is to think about, when trying to figure out if the output is good or not, having two ideas about what it could be. It could be a reference-based metric, and this is where we have a ground truth answer. So when I'm talking with a travel assistant and I say, I want to book a flight, was the booking flight tool called by the travel assistant? Okay. We know what it needs to be there. So we have a ground truth answer. This is one type of metric. We have a reference-free metric. We have reference-free metrics as well. So when a correct response is subjective, or there can be multiple correct responses. So did the travel assistant have a helpful tone? Did the medical information assistant offer a diagnosis? Did the marketing campaigns assistants copies sound like our company? Did the emails sound like the emails we used to send out? Okay. And we actually will treat these quite differently when we think about how we evaluate them as well. So thinking about the stages of evaluation, most people are still at vibes. Vibes, where you look at your results and your traces and you iterate. When we were looking at that LinkedIn profile app, perhaps when we saw it said to who is John, Hugo Bowne-Anderson, then we'd iterate on the prompt to avoid failure modes like that, catching things early, right? After doing things by vibe, you want to do more robust failure and error analysis. So this is robustly classifying failure modes and errors. After this, you want to think about doing automated evaluation. So this is having Python scripts and test sets for programmatic evaluation. So we want a gold standard data set of inputs and outputs and intermediates in order to, it's like having a test set in machine learning. So vibes are what happens when we're up here, right? And as we move, hopefully up and to the right, I mean, the way you move up and to the right is making sure you do more programmatic evaluation, have a good test set, essentially. So moving from vibes to evaluation, structure matters, because when you're doing vibes, it's subjective, like, oh, that seems better. Whereas when you have an evaluation harness, which is a script and a test set, you have objective measurable metrics. Evals by vibes are inconsistent, difficult to repeat reliably. You don't have a historical baseline, hard to communicate results clearly, and impossible to maintain consistency across team members. Whereas a harness, as I said, you've got objective measurable metrics, repeatable structured evaluation process. You can clearly track improvements and regressions over time, document results, easy to share and analyze, and it's standardized and reproducible. So before we get there though, and when I share the slide deck afterwards, I'll share a few more resources. There are some skip slides talking about how you build this failure analysis process, but essentially you want to go in and manually annotate a bunch of your data and categorize what's working and what isn't, and then rank failures. So if you see after you rank your failures that 30% are hallucinations, 25% are retrieval errors, 20% are incomplete responses, and 15% are formatting issues, if you focus on the top two, you're able to perhaps fix over 50% of the errors already. Whereas if you fix something which may be more obvious or salient, like formatting issues, you'll only be improving 15% of them, right? So that's one of the reasons this type of failure analysis is so important. Now, when automating your evaluators, what do we measure? We want to have a metric for each failure mode. We also want to I just got a note from Israel saying, great session. We have less than 5 minutes more to the next session. I was under the impression this was a 90-minute workshop. So if we could just confirm. Yeah, I'm looking at the schedule, and the schedule says 90 minutes. So if you wouldn't mind confirming that, that'd be great. Otherwise, maybe I'll just set up. Okay, cool. Great. Thanks, everyone. You keeping me on my feet there. So what do we measure? We want a metric for every failure mode. I'll show an example in a notebook in a second. For reference-based, we have a golden reference. We have a test set. For reference-free, we have rules or properties, and that's what we'll see examples of. And you can use test sets for examples for these as well, okay? Each failure mode should have its own evaluator, and code-based, use code-based evaluators when it can be checked with rules. So these would be like exact or fuzzy matches, testing for JSON, that type of stuff. And use LLM as a judge. And if you haven't encountered this term before, or you've seen a bit of it, but it seems like jargon, it is jargon. This is essentially writing a prompt that an LLM uses to judge the output of another LLM. And you'll use this when it requires some judgment requires judgment of some sort, like, is this email an appropriate one to send? Okay. And as we'll see, LLM as a judge, a few heuristics for how to build them. You want to give it clear and specific evaluation criteria and pass-fail definitions. Give it a few examples and structured output formats as well. So this is the type of prompt we'll send to, we'll give to an LLM to evaluate, okay? And I'll show you this in the notebook soon, but this is to evaluate an email. So you are an expert evaluator assessing outputs from an outreach automation system that drafts personalized emails based on a recipient's LinkedIn profile. Your task, determine if the assistant-generated outreach email is appropriately personalized and so on. We give it evaluation criteria. We give it definition of pass or fail. We give it profile dimensions to consider. We tell it the output format. We want its reasoning. We want JSON with 2 keys, reasoning, and a brief explanation, and pass or fail. We give it a few examples, right, of this one is a fail because it's generic and makes no reference to the recipient's background. This one is a pass for a few reasons, right? And then we tell it to evaluate the next email based on a particular summary, and then we say your JSON evaluation. Okay, so this is an example of how you write an LLM judge to evaluate. Now, I do want to say it's incredibly important to align your judge with your own evaluations. And this is something that you do over time, right? You'll build a judge, see what the output looks like, see how it judges, see how you would judge, and you iterate on the judge. And I won't go through all the details of how to align here, but you can even do it in a spreadsheet. And this is the one Philip Carter did at Honeycomb with Hamel Hussein, I think. And after 3 iterations, they saw agreement went from 68 to 94%. And they did that in a spreadsheet. So let's now go back to GitHub in order to see these types of systems at work. And we'll finish with the LLM as a judge in this notebook. So I'm going to NB2 in GitHub. And what we'll be doing here is, for those who are coding along after the fact, you will need to select your kernel for your notebook, okay? And you'll click, it'll say select kernel here, and you'll go up here. You may need to install a Jupyter extension or something like that, but then you'll select Gen AI First Principles. Now, I'm going to restart the kernel here. I mean, famous last words. I'm going to clear all outputs. I'm going to run all of it, okay? And I'll just talk you through briefly what we'll be doing here. I don't want to spend too much time in this notebook, but I do want to give you a sense through code of what we just talked about, okay? So we're going to build a practical AI pipeline, the one we just talked about, that automates this workflow where we turn unstructured LinkedIn profile text into structured JSON. Then we'll use that structured data to write a personalized outreach email. And then we'll build an LLM as a judge to automatically score the personalization of our emails. We'll explore some prompt engineering techniques in the meantime, like schema definitions, persona constraints, to iterate from a basic baseline to a working prototype. So first, we're doing our imports, setting our API keys. Then I'm loading in my LinkedIn data from the directory, and we'll see profile loaded, first 500 characters, Hugo, etc. And then I want to extract some structured outputs from JSON. And why do we want structured output? And so we can feed it easily into the next step. And I want to extract, what do we want for a recruiter? Like name, current title, location, years experience, top skills, recent roles, education. And this used to be 5 actually. And for the purposes of this, I changed it to 2, but left that in there. The things you don't catch. So let's test 2 different prompt engineering approaches here to see which works best. In the first one, I'm literally just saying to it, extract it as JSON and give us the key information. Now, this is what we used to do in the early days before quote unquote JSON mode, but we'll see here, right, what it actually does. It looks like it's JSON. But it's actually, what you'll notice is it has 3 backticks beforehand. So it's actually a markdown version of JSON. And presumably that's because a lot of these things, a lot of these models are trained on, internet scale data. So we have a great question from Jonas. I've mentioned JSON quite a bit. So before I even answer the question or ask the question, JSON is like a decades old industry standard, right? So that's one of the reasons we use it, and we may be stuck in some sort of local minimum, but it's been around since the early 2000s. Okay, and you've very rightly asked about Toon, which I think is an incredibly useful and thoughtful alternative that we all should start thinking about using more. But in terms of adoption of tools to put across like the global enterprise of software, I honestly think we probably should be more conservative in our adoption. I think JSON, there are lots of challenges with it, but it's incredibly useful and wonderful in a lot of places as well. But I do think we should be entertaining a lot of other options. So, of course, what I do then is, and this is kind of like the iterating via vibes, like evaluating via vibes, right? I was like, oh, this doesn't actually give me JSON, and now I should probably get JSON. So I actually use JSON mode here, and I tell it the required fields, and I tell it some rules. If a field is missing or unclear, use null, right? Because I want these things to be more programmatic and more repeatable. So let's see what happens then. And variation 2, this looks good to me. It doesn't have the backticks. And when I tested it for JSON, it came out as valid JSON, which is great. So that looks good to me. Now, what we do is we turn this into a personalized recruiter email. So for some reason, I've repeated, to put in the pipeline, I've repeated the JSON extraction. Now I'm giving a job description of a senior AI ML engineer here, and I won't go through the details there. And then I say, write a recruiter email to this candidate, right? And I give them the JSON dump of the data and the job description. It goes, Dear Hugo, my name is Blurg and I'm a recruiter at your company. I came across okay, pretty generic. It's not actually that bad though, but it's a bit LLM sloppy and I'd like it to be more specific as well. So what I then do is I give it the same, I tell it it's a professional technical recruiter. And in fact, when you tell it's a professional technical recruiter, it will write emails that are more appropriate for technical positions. And I say, keep it under 250 words, reference 2 to 3 specific things from their background. Do not use phrases like, I hope this email finds you well, or exciting opportunity, right? So, and this is when iterating via vibes, like just notice what types of things it generally does. And I have like templates. A lot of us have templates and boilerplate of what we tell it not to do, right? So your extensive background as an independent data and AI scientist, coupled with your impactful leadership. Okay. So I'd iterate again and tell it to not use words like impactful and that type of stuff, but it's getting better. So then what we do is we just combine both into a 2-stage pipeline where we extract it, generate the email. And one reason decoupling it like this is so useful is you can test and evaluate at each step. And if the errors, if there are hallucinations in your LinkedIn data extraction step, you can actually see that and start to do evaluation at that level and improve your system there, as opposed, once again, to having like one giant black box. So now I want to show you the LLM as a judge to evaluate quality. So how do we check if this pipeline is working? So for structured data, we can use code-based checks. So JSON loads, right, to verify the JSON is valid, or asserting years experience as an integer. For content quality, we can't use code checks, code to check if an email is polite or relevant. For this, we need judgment, right? So we use an LLM as a judge. Once again, aligning these will be very important, but this is the judge that I showed you in the slides, okay? And then what I'm doing is I'm giving it several examples. So of a LinkedIn summary of an email, of a LinkedIn summary, an email, and so on. And then what I'm telling it is so I'm sending it to Gemini 2.5 Flash and giving it essentially the LM as a judge as a prompt with each of these pairs of LinkedIn summary and email, and then looping over them and seeing what the judgment is. So check this. One email is, Hi, Sarah, I saw your work on conversational AI at TechCore. That was a joke name, of course, and was particularly impressed by your focus. Would you be open to a brief conversation about the challenges you face with model evaluation? This is actually really, really interesting. It gave it a pass. I'd probably iterate to say this isn't quite a pass yet, but it references something I do explicitly. I also kind of like we should tell them, okay, I'm sorry, we do tell them about a job there, but we probably should say, we want to talk to you about a position. This is kind of a cheeky way, because I always love talking about the challenges I face with evaluation, but better or for worse, this is given a pass, this is given a reason, then the next one, this starts hi there. That's a fail immediately. Use the person's first name, okay? So give that a fail. This email is completely generic. That's great. Email 3, well, hi, once again, no name, fail. You can go through some of the more details there. This is interesting. I got it to write one which actually says the first name, still gave it a fail, but because it's relatively generic as well. Now, for those of you who are interested and excited about this, what you can do is actually start to generate emails and apply this LLM as a judge to to the emails you've generated, and then iterate on the judge prompt. So we've in a whirlwind, we've gone through structured extraction, grounded generation, and automated evaluation. So will give us the building blocks for creating more reliable and testable AI applications. I see Philip has a question. How about the agentic aspects of your LLM? Which agentic aspects? Because we haven't really talked about agents yet. None of what we've just gone through is really that agentic, right? And we're about to get into agents. But I'd be interested in what you mean by that question. So if you can clarify, that could be cool. So doing things. We want LLMs to do things along the agentic spectrum, right? So LLMs can generate text, but can they take action? So one example we've just been working through, were we actually to hook this up to an email generator, like actually sending the email at the end, that would be slightly more agentic, right? I'm kind of joking here because triggering an email send is like the easiest part of this system as well in a lot of ways. And also, I don't know if you want to like actually send it out without someone looking at it briefly, to be honest. But when thinking about building agents and working with AI agents, the way we think about it is, start with LLMs, then augment them, then combine them into workflows and move along the agentic spectrum this way. We've already gone through Anthropic's vision of the augmented LLM, which is really how, we've all been thinking about it for a while, but they crystallize in a really nice way. Before, getting an LLM to do 1,000 things, do you need memory? So start thinking about that. Do you need retrieval? Then what type of tools do you need? And a lot of the time, for research, for example, having a bash tool and a search tool, having two tools can get you a long way. And then what Anthropic talks about is start looking at the patterns that can help you build out your workflows. And they identified like 5 of the most common patterns that people using Claude will use. And this is the chaining one. And we've already seen this in the example we just built, right? We have a LinkedIn profile going into an LLM, getting out structured output. If it gives valid JSON, perhaps some other conditions, we then pass it to an email generator and out. That's exactly what we have here. Another example would be if we want to route things to different LLMs, perhaps if we're trying to generate an email to send to an executive, we actually want a better LLM to create that email because we want it to be more careful, or we want to use more of its chain of thought or something like that. And if it's to an IC, maybe we go along one of these paths. A pattern that I use a lot and that I love is the evaluator optimizer pattern, where you could imagine, for example, an LLM generating an email and another one being the evaluator. Now, this isn't quite an LLM as a judge. An LLM as a judge is something static, which looks at it after the fact. Well, a lot of the time. This is an evaluator, which will be involved in the production loop, where it could reject it, give it feedback, and then it would draft it again, and so on until we have accepted output. And note, this is cyclic, and we would want some time out at some point. We wouldn't want this to go ad infinitum. So what is an agent then after all of this? And we've really settled on, one of the most useful definitions for developers is it's a program where the LLM output controls the workflow. So it's not where we're writing the deterministic workflows and LLMs are doing non-deterministic stuff inside. It's where the LLM output controls the workflow. This is from Hugging Face. Eugene from Amazon said something similar, and this is from the Anthropic blog post. So workflows are systems where LLMs and tools are orchestrated through predefined code paths. Agents, on the other hand, are systems where LLMs dynamically direct their own processes and tool usage, maintaining control over how they accomplish tasks. So, in wonderful tongue-in-cheek, Hugging Face style, what's an agent then? It's just a for loop, always has been. Now, we'll look at a bit of code in a minute because I think it's really instructive. But people who are doing this for the first time often get caught up on the fact that we're actually doing 2 LLM calls. So we're putting the prompt into the LLM, and then the LLM will quote unquote decide what to respond. It will either give text tokens as completion, or it will trigger a function call or a tool call, and it will put out the function name and the argument, and it will still be tokens and text actually. But then the developer or our framework's job is to parse that and then execute the function, and then send the result of the function call back to the LLM, and it will do that again. And if it's one tool call, it will then give a completion response. And we'll see an example of that in a minute. But I do want to say, when building from the ground up, in terms of understanding your system, use an LLM if you want to just generate text. If you want to retrieve external information and use APIs and tools or predefined multi-step tasks, use an augmented LLM. If you want the LLM to control multi-step tasks or adapt the workflow dynamically, use an agent, but buyer beware there as well. And I'll say a few words about this soon. I do want to say, I did earlier this year in July, I think, or something, have a post that went to #1 on Hacker News. And I'm not saying this merely as a humble brag, although that's probably part of it. I actually wrote this out of frustration, and I didn't expect it to resonate. And the reason, besides the minor humble brag here, I'm mentioning it, is because for those who are like, if you're starting out on your journey here, or if you're coming up against issues with building agents, don't think you're alone. Everyone has been burnt, and everyone continues to be burnt when trying to build these like big agentic systems. So starting small with augmented LLMs and workflows is one other way out of proof of concept purgatory here. The key takeaway is, if a simple tool call works, don't build an agent. And we have 12 minutes left. I have a few more slides I want to show. So what I'm going to do is go through one notebook briefly, the function calling one. So I'll restart, famous last words again, and run all. And so what we're going to do is, instead of just generating text now, we know models can like ping APIs or make requests to run code or query a database or search the web. Okay, so I'm going to show an example of this OpenAI function calling and Gemini function calling, and using a weather API. And then I'll actually quickly show you a case of doing a web search as well. So we've been through this. So what I want to show you here is, what we're going to do is, we define a function, the get weather function. We describe it to the model using a schema, call the model with the function available, execute the function with the model's provided arguments, and send the results back. So now let's see this in action. We define the function. So we're using a get weather function here. Fetch current temperature from this particular API. Okay, so we've defined that. Now we need to tell the model what the function is. Okay, and so, you know, for OpenAI we need to do this, but we give it a name, we give it a description, and model descriptions slightly less important than they used to be. Sorry, tool descriptions, but still very important. Models are far better at inferring what tools to use based on descriptions now. But the better the description you provide it, the better off you'll be. And look, I'm telling it what properties as well that it and it requires latitude and longitude there, right? Because that's what the API takes. So then I call the model. I'm using GPT-5 Mini here. I say, what's the weather like in Sydney today? And I send that as a message to GPT-5 Mini, and I send it the tools as well. And it's one tool that I've specified above. Now look at this. This is wild. It quote unquote recognizes to use the tool, so it doesn't output a response yet. It says we'll use the tool. What's even wilder, so it gets the correct tool. Of course, we only have one tool. it also knows the latitude and longitude, right? So this is why specifying this well can be so helpful, because GPT-5 Mini, I've told it Sydney, but in its weights internally, it knows the latitude and longitude, quote unquote, knows the latitude and longitude of Sydney, and it specifies them for us. So that's relatively clever and was counterintuitive the first time I saw it. So now we have the output, right? But we need to take this output, send it to the API, which we do here, and get the result. Okay, let's just make sure the result, no, that result's going to be of some cells below, I'm sorry. So the result should be a temperature, right? Then what we do is we send the results back to the model, right? So we take our message, and we append the result to it and send it back to the model and get the completion out. And we see the current temperature in Sydney is 19 degrees Celsius, etc. And this is interesting. GPT-5, because it's super chatty, he says, would you like a forecast, chance of rain, wind info, or hourly update? If you're building a system incorporating this, where someone puts in the name of a city and they get out the temperature, you don't want to have this type of question. So you'll want some check to make sure that it doesn't ask a follow-up question like this. Yes, Akshaya, the recording will be available. Now, let's just quickly look at what Gemini does. See, this is really interesting. I did this with Gemini 2 Flash, and I told it, get current temperature provided in coordinates when the user asked about whether in a city you should determine the latitude and longitude. I had to do all of that. It wasn't as clever as GPT, even GPT-4 Mini. And we can see here, it didn't quite work. And sometimes this does, and sometimes it doesn't. So you want to think about the non-determinism there. So when I passed the actual result to it, it says no function call. I need the latitude and longitude, right? Now, before wrapping up, I do want to say there are so many other cool tools you can use, okay? You can enrich your data with search, for example. And so we've looked at LinkedIn profile, getting structured output from that. Let's say you looked me up and it didn't have the information you wanted for me, right? Now, if you knew that was a possibility, you could then attempt to programmatically enrich your data using search, right? And tool calls. So what I've done here, and this is, I like doing this type of thing. First, I'm not even, this is when I know that I'll want to check get someone's website, right? So what I essentially do is use Tavily, a web search tool, to query Hugo Bowne-Anderson, but you can put any name in there, and then I'm getting the first 3 responses. So this is like the top 3 in Google, but Tavily, right? And then what I'm doing is I'm sending to GPT-4 Mini a prompt to say I'm looking for the official personal website for Hugo, important context, etc. If a website belongs to someone with the same name but a different profession, reject it, and asking it to get the correct website. Now, look at this. This is really weird, and I'm not a fan of this, actually. But Tavily's first 3 results for me are a YouTube video on how to build and evaluate AI systems. That's cool. My LinkedIn profile and my Twitter handle for some reason. I kind of want it to be my personal website. So, and what the prompt did, it said no good matches found. It didn't like any of these because I specified identify the personal website, and I don't want LinkedIn or Twitter or anything like that. So what if I increase this to 5? Cool. So the 4th one here was me. And so it found my website. Okay. Cool. So, and then what you could do is you could feed that into your structured output pipeline, right? Stephen has a good question. What are not recommended tasks for LLMs? And he says ThoughtWorks Tech Radar says text to SQL is not recommended. Look, I'd say if your schema is not super complex, text to SQL's pretty good, to be honest, these days. So I don't know when they said that. And you can put guardrails around or constraints around the output as well. I'll try to follow up with respect to your question. Because I think it's a very good one. We only have 4 minutes left, sadly. I do want to summarize what we've just gone through, though. We've seen how tool calling works, and we've seen the model doesn't execute functions; it requests them, and we control or need to build what it actually runs. Now, I'm not going to go through the fourth notebook, but this fourth notebook identifies all and gives examples with respect to the email generation pipeline of all the workflows identified by Anthropic, from prompt chaining to routing to evaluator optimizer. So just to wrap up in 3 minutes, this is going to be a bit of a hustle, but I did want to say a bit about the two cultures of AI agents, because I have some cognitive dissonance. I wrote this post a while ago called Stop Building AI Agents, and yet I use AI agents every day, and I need to explain that, okay? On top of that, to create this image saying I used AI agents every day, I used an AI agent. I used ChatGPT, and I didn't tell it use DALL-E 3, but it figured out what tool to use to create that image. So how can I be telling people to not build AI agents when I use them all the time? And I realized it has to do with the amount of human supervision we have as well. When I say stop building AI agents, I'm really talking about when you're building consumer-facing software that has certain expectations around its predictability, right, and its determinism, and it won't necessarily have a supervisor there with it, right? And then you're in this dangerous territory where you have high autonomy and not a serious human in the loop. Whereas with tools like Cursor and Claude Code and deep research, you have high agency and strong supervision. There's also a dimension of risk that we don't have time to talk about now, but I think are increasingly important. But when you do have high agency and strong supervision, I think building agents can be incredibly powerful and incredibly useful. And I will encourage you all to check out another post by Anthropic from June this year, that if someone wants to Google and put in the chat, they can, called How We Built Our Multi-Agent Research System, which I really think speaks to a lot of the advances in how we can think about building large-scale agents at the start, as opposed to starting small. Just the takeaways for this section for building agentic software. Most of the time, you want to start small, use augmented LLMs and workflows first, then introduce a few tools as needed. Only then move on to agents. Recognize observability and evaluation as a key. But then again, don't be afraid to build complex agentic systems when there's going to be strong supervision and a human in the loop. To wrap up, important, super key first principles for building AI-powered systems. Recognize we're working with AI, with API calls. We've got inputs and outputs. Using Python with those a lot of the time. System user prompts, structured outputs. Principle is LLMs are non-deterministic, same inputs, different outputs. A lot of the time with user-facing software, not even the same inputs. Another principle is logging, monitoring, and evaluating and tracing. You need to capture your data. Fourth principle, evaluation is key. You need to look at your data and results and quantify performance. Fifth principle, iteration. Iterate quickly using prompt engineering, retrieval, fine-tuning, changing business logic, all of these types of things, iterating on your system. We are at time. I would like to thank you all. We've got some more interesting questions that I'd love to answer. I don't know if we're chatting on Discord or where that's happening, but hopefully we all get to speak soon. If you do want the slides, just put your email in the form here and I'll share them with you afterwards. But I would love to thank you all for joining, for the wonderful interaction throughout. And I hope we all get to chill out at the conference a bit and perhaps do some workshops and build some fun things together in future as well. Please, we can connect on LinkedIn and Substack as well. and appreciate you all. And thanks, PyData Global, for having me once again, and for I'm excited for the rest of the conference.